Alright guys, welcome back. We're going to be solving another question from second chapter of Meriam textbook, and we have a sheet of an experimental composite which is subjected to a simple tension test to determine its strength along a particular direction. We know the composite is reinforced by the Kevlar fiber shown, and a close-up showing the direction of the applied tension force F in relation to the fiber direction at level A is shown. So you can see the fiber in here, and we know the magnitude of the force F is 2.5 kilonewtons, and we need to determine the components of FA and FB of the force F along the oblique axis A and B. And we also need to determine the projections PA and PB of F onto the AB axis. So let's start with the first part of the question where we need to find the FA and FB. So for finding the FA and FB, we'll do one line parallel to A and one line parallel to B, and this is going to give us the FA, and this will be our FB, but there are some angles missing in here, and obviously this is our F, which we know is 2.5 kilonewtons. So we know this angle here is 50 degrees, so we have this angle here 50 degrees, and we know these two are perpendicular to each other. So that means this is 90 degrees, we have 15 here, that means here we have 40 degrees. And since we know the angle between A and B is 50 degrees, this angle right here has to be 50 minus 40, which is 10 degrees. And if that's 10 degrees, this one over here is 10 degrees because we have two parallel lines that the F is crossing those two parallel lines. And there is only one angle missing if we want to look at the triangle that we have on top. I'm going to highlight it in blue. So I'm talking about this triangle. And there is one angle missing in here, which is this angle right here that we need to figure out. And that would be simply 180 minus 40 minus 10, which will be 130 degrees. Now we can do the law of sines for that particular triangle that I highlighted in blue. So if we do the law of sine, we simply have F over sine of the angle in front of the F would be the angle that I highlighted in green. So 130 degrees is equal to FA over sine of the red angle, which is 10 degrees, and FB would be sine of the 40 degrees angle. And from here we know F is 2.5 kilonewton, and it's easy enough to find FA and FB. So FA simply will be 2.5 times sine of 10 degrees divided by sine of 130. This is going to give us 0.57 kilonewton. FB will be, so we're going to multiply these two divided by this. So will be 2.5 times sine of 40 degrees divided by sine of 130, and that's going to give us 2.1 kilonewton. If we calculate this with calculator, that was the first part of the question where we needed to find the FA and FB. And in the second part, what we need to figure out is the projection. I'm just going to clean up the figure and we can see it better. So in the B part, what we need to figure out is projection of F on A and B axis. So if we want to do the projection of F on A, we know this will be the projection. So we have a right angle here, and this time we're going to call it PA, and we have the same thing for B, another right angle, and this is going to be PB. And it's pretty easy now because we have the angles with the angles of F with A and B. We know this angle right here was 40 degrees and this one's 10. So it's pretty easy. We know that PA would be, so let's just find the P and PB. So PA would be F times cosine of 40. So we'll have F times cosine of 40 degrees, and PB will be F times sine of 40 degrees and PB will be simply F times cosine of 10 degrees, which is the two angles that F makes with A axis and B axis. So if we calculate each of these so we know F again is 2.5 kilonewton, same in here, and if we calculate PA, we'll get 1.91 kilonewtons for PA, and P will be 2.46 kilonewtons, and that would be the final answer for the second part of the question where we needed the projections. So since our A and B in here, the two axes are not perpendicular to each other, probably the best way is to go with the law of sine. And yeah, that would be all for this question. Please let me know if you have any questions or if you have a better solution to solve this. I'd be happy to discuss it with you guys in the comment section. You guys take care, and I'll see you in the next video.